Hey guys, what's up people? How are you guys doing? Hoping that all of you guys are doing good and taking very good care of yourself. Welcome back to today's session. This is going to be lecture number 7 for CBSE 10th, where we'll be talking about electric power and energy, and also we'll be solving some numericals based on that. And this is lecture number 7, which means that we have already done 6 sessions based on electricity chapter. So please make sure to watch all those recordings as well. With that said, guys, let us start off with a simple quote for today. And the quote for today is this, guys: failure doesn't mean the game is over, it means try again with experience. You know, probably heard this expression that failure is a step to success, and I totally believe that, because yes, the more number of times you fail, the better you learn about everything that is going on around you, and you can make yourself better to, you know, achieve the success that you want. But before we get started, let me introduce myself. My name is Anoop. I'm a Master of Science here with Vedantu. A very warm welcome to all of you guys out there. Hoping that all of you guys are doing good once again. So let's get started with today's session, guys. So we have done all of these topics before, that is current and potential difference, Ohm's law, resistance, and factors affecting resistance series, as well as parallel. And in the last session, we also talked about the heating effect of electric current. So based on that last session, I'd given you a homework towards the end of it. Once again, awesome guys, good to see some amazing response. So here's the question: a water heater produces a heat of 2000 joules in 20 seconds. If the heater draws 1 ampere current, find the resistance find the resistance of the heating coil. So it's actually a very straightforward question. If you guys remember the formula, that is the heat produced in the circuit is basically equal to the the current flowing through the circuit, square of the current flowing to the circuit into the resistance into the time taken. So we know the current, we know the time taken, we also know the heat produced. We just have to find out the resistance. So rearrange the equation to get resistance. So R would be equal to H divided by I square into T. So we know the value of H is 2000 joules divided by the value of I is 1. So I square into time taken is 20 seconds. So 0 gets cancelled. So that's basically 200. Yes, so the answer to this question would be 100 ohms. As simple as that. So 1 square is obviously 1, so the answer would be 100 ohms. Congratulations, people. So here are some of the superstars from the last session. We have Kavya, Krishna, Afia, Hemalata, then Parth, Harihar, Shubham, and also Jaya. Congratulations, guys. Superb, keep up the good work, and I hope to see more such amazing answers from you people. With that said, let us not waste any more time and get started with today's session. So let's talk about an electric heater and an electric furnace. Now, a water heater or an electric heater, okay, yeah, you call it as a water heater. So the thing that is used in your, your washrooms and all to keep the water, rather than heating up the water on your stove, you basically go with this. So you turn it on for some time, and then the water is hot, you take bath, and then you leave. And there is another thing called as electric furnace, wherein that is mostly used in laboratories, or maybe in the manufacturing industries, where they want to manufacture steel, or in the manufacturing of any other kind of alloys and stuff. We use this. So there's a very high temperature that you attain in an electric furnace, and the temperature in a water heater is pretty less. In both the cases, however, you are converting electric energy to heat energy. That's what's happening. So when you turn on the switch, what happens? As the current is passing through the conductor, there'll be a heating coil, or something called as a element, or heating element, that converts, because of the resistance offered, it converts into heat energy. So that is what is happening in both the cases. There's heat energy produced over here, there's heat energy produced over there also. That is in an electric furnace. But here, the temperature that you attain is somewhere like around 50 degrees Celsius to 60 degrees Celsius. Definitely not going to be more than that, because if it's definitely more than that, then that can burn your body as well. So yeah, we keep it around 50 to 60 degrees centigrade. Whereas if we talk about electric furnace, here also it's the same thing. It is converting electrical energy to heat energy, but then over here, the temperature that you attain is somewhere between 1000 degrees Celsius to 1200 degrees Celsius. There's a massive difference, very clear, just by looking at the sheer number, 50 to 60 degrees Celsius and 1000 to 1200 degrees Celsius. That's a massive difference. So the question is, what is that major change? In both these cases, guys, the electricity, or basically you're converting electrical energy to heat energy. But the rate at which the energy consumption happens, or that electrical energy being consumed or converted to heat energy, is way more greater in an electric furnace compared to a water heater. I'll repeat it one more time, guys. The rate at which the energy consumption is happening, or that the electrical energy is getting converted to heat energy, the rate at which it's happening is far more greater in an electric furnace compared to a water heater. As simple as that. So there's this quantity which tells us the rate at which an electric energy is consumed. That is what is called as electric power. The rate at which electric energy is consumed or dissipated in the form of heat. That is what is called as an electric power. So if you look at the formula, guys, power is equal to heat dissipated by time taken. So heat dissipated, you already know that is H. H, we have already seen the formula, that is VIT, or you can also write as, in this case, let's not consider the resistance or anything. So let's just keep it as VIT, that is the voltage into the current into time. So if you divide VIT divided by T, TT would get cancelled, and what you're left with is basically V into I. So power, one of the formulas of power is V into I. There are other formulas of power as well. So this is one of the basic formula. Power is equal to, directly, it's nothing but current into the voltage. That's it. Alright, that is what is power. Now, what exactly is power? Just to define it one more time, the electrical energy or dissipation that is happening per second in an electric circuit, or the energy consumed or dissipated per second, is what is called as power. So basically it's nothing but energy. You can also represent it as energy by time, which is the heat energy that we just talked about. H by T, VIT divided by T. TT gets cancelled, and H is equal to V, or P is equal to V into I, where P is power. Also, apart from this, guys, the SI unit of power is nothing but watt, and these are some of the formulas to calculate power. So your V into I, your V square into divided by R, I square into R, or W by T, where W is nothing but work done. So these are the formulas that we use to calculate power. Now I want all of you guys to quickly pause the video for a second and take a quick screenshot of this, because this is going to definitely help you out in your final exams. You don't have to run through your entire textbook looking for these formulas. It'll be much more easy. It'll be much more handy if you want to keep a record of all these formulas. So quickly take a screenshot of this. Alright guys, with that said, let us now get into understanding about the commercial unit of energy. So here's the thing, guys. In our households, in our every household that you take, you have a lot of electrical appliances. You have fridges and fans, and then you have tube lights and TVs and ACs and whatnot. A lot of electrical appliances. So if you look at that on an everyday basis, we're consuming a lot of energy. So let's take an example, right? Imagine there's an AC, which the power rating of that means the minimum power required to run it is around 500 watt. So that is the power of that AC. That's around 500 watt. Let's say that the energy consumption per hour is basically what? So 1 hour is nothing but 16. I have to convert to seconds. So 1 hour is 60 minutes, and 1 minute is 60 seconds. So 16 to 60. So you'll get us 3,600 seconds. All right. So 500 into 3,600 would give me what is the energy consumption per hour. Now let's say that this AC is turned on every single day for 3 hours. So it'll be into 3. And let's say that it's done for the entire year. So into 365. So if you put out all these values, you will get a gigantic number as something like this. So this number is really huge. If you think about it, it's super huge. That's like 197 crores, 10 lakh joules per year. So it's not a viable option to represent this with such big values. It's very hard to remember, and it's also not right, because people might get confused. So what we can do is, we have another unit to represent the same exact value in a much more simpler manner, and that is what we're going to look at right now. So what, like I told you, is not a practical way of representing things, because again, it's a lot of numbers, and people can easily mismatch or miscalculated. So to make our lives a lot more easier, we have something called as kilowatt hour. So the commercial unit in our households as well as in industries, where the massive industries and all that, over there we calculate in kilowatt hour. So what is this kilowatt hour or something? But you see, if you talk about 1 kilowatt, sorry guys, 1 kilowatt is equal to 1000 watts. 1000 watt. And 1 hour is basically how much? Is 3,600 seconds, right? Because it's 1 into 60 into 60, so that's 3,600 seconds. So if you multiply both of this, you would get what is the value? 1 kilowatt hour. So if you multiply 1000 into 3,600, you'll get us around 36 lakh joules, which you can write it as 3.6 into 10 to the power 6 joules. So 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Now if you want to calculate the same thing that we just did before, that is this 197 crores, if you want to convert it to kilowatt hour, just divide this entire value by 3.6 into 10 to the power 6, you would get the answer in kilowatt hour. As simple as it. So whatever value you get in watts, divide that value by 1 kilowatt hour, the value of 1 kilowatt hour, you will get the answer for this. That's it. So you can convert that to kilowatt hour just like that. That's it, guys. So that's it now, guys. I hope that all of you guys have understood the topic. Right now, as always, we're gonna get in some quiz as well. Before that, one last thing I want to tell you guys is this, that is, if you talk about your electric meters that you have at home, which denotes how much energy consumption have you done in in a day or in a month, like where every month the electrical the people, what do you call it, the electricians come to your home and they give you a notice, like it's a bill. So basically it's an electric bill. So over there and all, it is actually represented in kilowatt hour. Just to make our lives more easier, we have all represented that in kilowatt hour. So with that said, guys, let us solve some questions now. Get to see how I'll see how many of you guys have understood the topic. Now again, guys, I want all of you guys to write down the answers in the comment section below, and if you have any doubts as well, put it down in the comment section below so that I can answer that as well. Alright, so here is the first question. A device draws 3 ampere current from a voltage supply of 220 volts. The power of the device should be what? 220 divided by 3 volt, or 1980 volt is a 223 watt or 660 watt. So they've given you the current, they've given you the power supply, the voltage also. You're supposed to find out what is the power. So it's a very simple question, guys. The first formula that we looked at, that is power is equal to voltage into current. So voltage is 220 volt into the current is 3 amperes. So if you multiply that, that'll be 660 watt. As simple as that. One of the most simplest question, no? Exactly. So that is the answer, guys. The right answer would be option number D, that is 660 watt. Moving on to the second question. Here we go. An electric pump A lifts 100 kgs of water to a height of 10 meters in 5 minutes, whereas pump B can lift up the same amount of water to the same height but in 10 minutes. Which pump has more power? Pump number A, pump number B, both have the same power or can't same. Now guys, one thing, just by looking at the question, you can directly say it's pump number A, because this takes lesser time compared to this. This pump number A takes 5 minutes, whereas pump number B takes 10 minutes. But if you want to prove it mathematically, you cannot just write it like that. You have to calculate it. So to just calculate that, so we do that power is equal to work done by time. Now in this case, because the work done is against gravity, or the work is done by the gravity, so it will be what work done would be mgh, basically the potential energy, or the formula mgh divided by T. Now in this case, for the first one, we'll take it as P1 for the first one. Okay, so P1 would be what? Mass is 100 kgs. The acceleration due to gravity, I'll take it as 10 just for my ease, and it's 5 minutes. So see, guys, everything is in, if we talk about acceleration due to gravity, it's 10 meter per second square. So convert that 5 minutes to seconds. So 5 into 60 it would be, so 5 6 are 30, so that's 300 seconds. So into 300, sorry, into height is 10 meters, sorry, height is 10 meters divided by 300 seconds. That would give you the answer. So 0 0 gets cancelled, 0 0 gets cancelled. So 3 3s are 9, 3 3s are 9 again. So 33.33, something like that you'll get. So 33.33 watt would be the answer for the first question. For the first part, the pump number A. For pump number B, on the other hand, again the same exact formula, just as the value of time would be a little different over here. So again, mgh divided by time. M is 100. Acceleration to gravity, I'm taking it as 10. You can take it as 9.8 also, just to make my life easier. I'm taking it as 10, and h is again 10. Time taken is 10 minutes, so into 60 seconds, that's 600 seconds. So 0 0 gets cancelled, 0 0 gets cancelled. 6 2 3 6 2 5 10 0 3 1 3 3 yes, so 3 1 is 3. Yes, so I think it'll be around 16 if I'm not wrong. I think I've made some calculation mistake over here. Alright, yes, I think, okay, yeah, alright, I think I've made some calculation mistake. Just check the calculation, guys. Just check the calculation part. Hold on, let me just erase that a little. Hold on. So that's yeah, 2 3 6 2 5 10 0 3 1 3 all right, 3 6 18. All right, so it'll be 16.66. Sorry, yeah guys, it was correct. So 16.66 watt would be the answer. As simple as that, guys. So just by comparing the values, you can clearly say that pump number A is much more powerful, or it has more power compared to pump number B. So by that, guys, you can come to the conclusion that A is correct. Simple as that. Alright guys, moving on to the third question. This is the third question, guys. The wattage of a bulb is 24 watt when it is connected to a 12 volt battery. Calculate its effective wattage if it operates on a 6 volt battery. And this is a board exam question. This was asked in 2011. So these are the options: 6 watt, 3 watt, 12 watt, or 24 watt. Now this question, there are two ways to do it, guys. There are two ways to do this question. First of all, write down the given data. So P1 is equal to 24 watt. They've given you the voltage. V1, I'll take it as V1 is 12 volt. They've given you the effective voltage. You're supposed to find out what is the effective voltage if the voltage is if the voltage is 6. All right, so we have to find out what is P2. V2 is given as 6 volt. So you're supposed to calculate what is P2. So what you can do is basically find out. There are two ways to do it. Like I told you, one thing what you can do is that P is equal to what? P is equal to V square by R. This is one such formula, because there's voltage given and they have not mentioned the resistance. So what you can do is that find out the value of resistance over here. So for the first one, you can take it as 24 is equal to 12 square whole divided by R. So you can find out the value of R like this, and then substitute that in the second equation, that is P2 is equal to V2 square divided by R. You can put it on over there and find out the value of P2. That's one way to do it. Or what you can do is that you can directly divide P1 by P2. That is also absolutely correct. So this is one way to do it. So you'll get this as what? So R is equal to 12 into 12 divided by 24. So 12 to 24 to 6, 12, 4. So you'll get it as 6 ohms. Then put it on the second equation. So P2 is equal to V2 square divided by R. So what is P2? P2 is basically, you don't know what is the value of P2. So V2 is 6 square. So 6 into 6 whole divided by 6 gets cancelled. So you get a 6 watt. So that will be the answer, guys. So P2 would be 6 watt. One way to do it is this. Or if you want, you can also do it the other way. I'll show you the other method. Also, this is one method to do it. If you want to show the other method, this would be a little bit more, I mean, it's actually both the methods are pretty simple. So there's nothing like too complicated about it. Whichever you find you can remember better, go with that. So this is the second method, guys. What you can do is divide P1 by P2, which would be equal to V1 by V2. Because see, guys, they have not mentioned anything about the resistance. So I'm going to assume that resistance is constant. So because P1 is equal to V1 by R, V1 square by R, and P2 is equal to V2 square by R. R gets cancelled because it's constant. So you'll be left with what? V1 by V2. So you can put down the values over here. V1 is given as 24. This I'll take it as X for now, just for my ease. I'll just take it as X. And V2 is 24 square divided by 12 square. Sorry, this is 12 square. 12 square divided by 6 square. Sorry. All right. Mistakes. Alright, one second, guys. So this will be 12 square divided by 6 square. You will still get the answer. If you just rearrange the equation, you will still get the answer to be 6 watt itself. So these are the two methods. Both of them are direct substitutions, and you'll get the answer. That is the answer for this question, guys. It'll be 6 watt. So the answer to this question would be option number A. That is 6 watt. As simple as that. Moving on to the next question, guys. Here's the fourth question. A bulb draws 2 ampere current from a voltage supply of 220 volt. This bulb is operated for 4 hours in a day. Find the energy consumed in the bulb by the bulb in 30 days in kilowatt hour. So you're supposed to find it in kilowatt hour. So again, very simple. These are the options: 52.8, 61.2, 78.2, or 45.9. So the question is actually pretty simple. So they've given you, you have to find out the power. So power consumption, the formula is what, if you remember it, they've given you the current, they've given you the voltage. So find out what is the power consumed. So it is basically V into I. So that's first of all, to find out the power, it's 220 into 2. So that gives you 440 watts. So this is operated for 4 hours. So that will be 440 into 4 into 3600 seconds, because 1 hour is 3600 seconds. So there'll be 4 hours. So into 4 into 30 days, so that'll be into 30. That would give you the answer. So whatever value you calculate, it'll be a very big value. You'll get it as somewhere around I don't know, around 1900 100000000, I don't know, something like that. It's a very big value. So yeah, this is the value that you're gonna get in terms of joules. Divide that by 3.6 into 10 to the power 6 to find that in kilowatt hour. So you'll get the answer. As simple as that. I didn't want to do the calculation because yes, you guys are smart enough to do the calculator. I use a calculator and do this. So it's if you calculate it, you'll get this as the energy consumed in that 30 days. Divide that by 3.6 into 10 to the power of 6. You will get the answer in kilowatt hour. So the answer to this question is 52.8 kilowatt hour. So that will be the answer for this question. As simple as that. Alright guys, moving on to the fifth question. Here's the fifth question. A device consumes 18 crore joules of energy in a month. If the cost of energy per unit is 3.5 rupees, what is the cost of operating the bulb monthly? Is it 125 rupees, 150 rupees, 175 rupees, or 200 rupees? It's actually a pretty simple question. So first of all, convert that to kilowatt hour. So that's 18 crore. So 1, 2, 3, 4, 5, 6, 7 divided by 3.6 into 10 to the power 6. So that's 36 so that's 36 lakh. So 5 zeros over here and 5 zeros over here as well. So 1800 divided by 36, you'll get it as 50. So 50 into 3.5 would give you the answer. So 50 into 3.5, the value is basically 175 rupees. So the answer to this question is 175 rupees. As simple as that. You just have to find out the answer in kilowatt hour, multiply that with the cost given, and you'll get the answer. So the answer is option number C, which is 175 rupees. As simple as that. So that is it, guys. That is it from my side for today. And as always, this is your homework for today. Let me know what is your answer in the comment section below. I want all of you guys to give me the answers. So here's the question. A 100-watt bulb is operated for 8 hours daily. Find the cost of operating this bulb for 30 days, assuming that the cost of electricity is 4 rupees per unit. So you're supposed to find out what is the cost of operating this for one whole month. That's about 30 days. So find out the answer. Let me know in the comment section below. Thank you for joining today's session, guys. I hope you guys enjoyed it. If you did enjoy it, leave a like and subscribe to the channel. See you all in the next one. Until the next time we meet, this is Anoop taking a leave for now. Thank you guys. Have a great night ahead. Bye. Take care.